This is similar to this week's problem of the week. I've just changed some of the numbers here. So we have this formula for drip rate with an IV. The volume that you're trying to distribute, you divide it by the time, and it doesn't necessarily have to be in minutes. You could do it by hour if you really wanted. And then you can multiply by the drop factor, and that would be the flow rate. Just to make sure that if you change your time unit from minutes to hours, you would change this to hours as well, right? So those units are key when checking your answer to see if it makes sense. Oh, there we go. Okay, try to get my cursor. Can't see it. Okay. So we have 1600 milliliters. That goes in for volume in the formula. And then the time is 4 hours. So I'm going to use parentheses and do 4 times 60. It's 4 hours times 60 minutes. That converts our time into minutes. If we want to multiply that by our drop factor, for this one it's 12 drops per minute. 12 drops per milliliter, I should say. And that equals the flow rate, which is what we're trying to solve for. Now, look, this is set up like the problem of the week question we had at the beginning of the course, because the temptation is probably to convert hours to minutes first, and then to multiply by 12 because they're right next to each other. But you have to read it left to right. With mathematics, multiplication and division are actually on the same order of importance. The way you decide between multiplication and division is by taking the first one you see when reading it from left to right. So the first thing to do is to take the 1600 and divide by 240. So that's going to be a bunch of decimals for mine. Carry out a bunch of them here. And then if you multiply, you get 80. So we have the flow rate. I just made up some numbers here. I don't know. That's probably not realistic, but it's 80 drops per minute for my particular problem. Part B says you got 1,600 milliliters you're giving over 4 hours. The question is asking us for milliliters per hour. That's what the units look like, milliliters, and then the word per is telling us to divide, like miles per hour. That's how many miles you've driven, divide by the number of hours you've driven. Milliliters per hour, that's the number of milliliters, divide by the number of hours. So those are the units we want. And to make that happen, you can take the full volume of 1600 and divide that by the 4 hours. And when you do that, your units are milliliters divided by hours, which is what our goal is at the end of this question. It's 400 milliliters per hour for 1 hour. That's our answer for part B. Part C says that this has been running for 50 minutes. How many drops have come from the IV? Up here in part A, we found out it's 80 drops per minute, right? So if you've run, that's what DTTS stands for, I guess. I'm not in the healthcare field, but that's what I've been told. Okay, so we got 80 drops per minute from part A. We're going to multiply that by 50 minutes. That way the minutes on bottom and the minutes up top cancel to tell us how many drops have been administered. That's 4,000 drops. Because minutes on bottom, minutes on top, those cancel out. 50 times 50 makes 4,000 drops. And then part D says there's a patient, 3 hours, there was 900 milliliter solution left. So it started with 1,600, ended up with 9,000. Back in part B, we found out that we're dripping 400 milliliters per hour. So the total amount administered after 3 hours should be the number of milliliters per hour, which we got in part B, multiplied by 3 hours. So we should have 1,200 gone. That means there should be, if you start with 1,600, there should be 400 milliliters left. There are 900 milliliters left, so this is running very slow. We're way behind where we should be at this point.